In this video, we're going to discuss the gradients of parallel and perpendicular lines. If you have parallel lines, just to recap, parallel lines are lines that never meet and are constantly the same distance apart. So the idea with parallel lines is just they have a slope, or any line has a slope. So the idea is that the slope of these lines is equal, which is why they never get close to each other. If the slope was different, it would eventually start getting closer and touching that other line. But because they have the same slope, they have the same gradient. So we say AB is parallel to CD. That means, or therefore, the gradients, M means gradient, small m means gradient. So the gradient of the line AB is equal to the gradient of the line CD. However, for perpendicular lines, the idea is a bit different. For perpendicular lines, lines that meet at a 90-degree angle, the product means multiply, so the multiplication answer of their gradient. So when you take their gradients and multiply it, you get -1. So if you say AB is perpendicular to CD, as we see here, the gradient of AB, which is this line, times the gradient of CD, which is this line, have to equal to -1. Alright, that is a property. Now, here's an activity on that. I have a line AB with 2 coordinates. I have a line CD with no coordinates and a line EF with no coordinates. Right, the first question is simple. What is the gradient of line AB? The gradient formula is simple. It's M is equal to y2 minus y1. Oh, I want to make a note at this point. Whenever you use the gradient formula and there's multiple lines in your question, let's specify what we're doing. So M of AB, meaning the gradient of AB, is equal to y2 minus y1 over x2 minus x1. Now, the first point is this one, as read from left to right, and this will be the second point. So this is x1 y1 and x2 y2. So your y2 value is going to be 3 minus -2 over 1 minus -3. You can then go ahead and solve that. You should get 1 2 3 4 5. Oh, okay, right. You should get 5 over 4 as your gradient for AB. Alright, so your gradient for AB is 5 over 4. Next, they say, what is the gradient of CD? So here's CD, and there's a little arrow on AB and CD. These arrows mean that these two lines are parallel. Okay, so that tells us those lines are parallel. Now, what is the gradient of CD? So firstly, those arrows told us that AB is parallel to CD. So let's write that down. Therefore, 3 dots in mathematics means therefore the gradient of AB is equal to the gradient of CD, the two parallel lines. Therefore, the gradient of CD that they want to know is equal to 5 over 4, the answer from the previous question. Alright, now that's done. The last question says, what is the gradient of EF? Now, EF, okay, so EF is here. There's a little square there. The square means that this is a 90-degree. That means these two lines are perpendicular. So CD is perpendicular to EF. So we know that. So let's write that down. So CD is perpendicular to EF, right? So we've written that down. What do we know about perpendicular lines and their gradients? So the gradient of CD multiplied by the gradient of EF, because they're perpendicular, has to equal to -1. And the gradient of CD we know is 5/4. So 5/4 times the gradient of EF is equal to -1. We can then solve this by multiplying both sides by the reciprocal of this function. So we can take times 4/5 here and times 4/5 here. We will therefore get that the gradient of EF, remember 4's cancel, 5's cancel, you just left with EF on the side, this whole thing disappears, is equal to -4/5. And that's the gradient of EF. So we found all three gradients using just this idea here. Well, the first one was obviously using coordinates, but the other two are using that idea.